By the end of the lesson, the students will be able to explain the effect of catalysts on the rate of a reaction, explain how catalysts work, describe homogeneous and heterogeneous catalysis, explain the characteristics of biological enzymes. Hydrogen peroxide, H2O2, can decompose to form water and oxygen. Look at the samples of hydrogen peroxide in the two test tubes. Note that only a few bubbles of oxygen gas are produced per second. Now, click the Insert button to insert a very small amount of manganese dioxide, MnO2, into test tube B. Click the Splint button to apply a glowing splint into both test tubes. What is the effect of the manganese dioxide on the rate of decomposition of the hydrogen peroxide? Click Next for the answer. Answer: it increases the rate of the decomposition of hydrogen peroxide. Manganese dioxide is acting as a catalyst for the decomposition of hydrogen peroxide. The action of a catalyst is called catalysis. The reaction is complete once there are no more bubbles of gas produced. Now, click the Remove button to drain off the solution left in test tube B, leaving the solid manganese dioxide behind. Click the Pour button to pour a fresh sample of hydrogen peroxide into test tube B. The manganese dioxide from the first reaction has the same effect on the fresh sample of hydrogen peroxide. It can be used over and over again. What can you deduce from this observation? Click Next for the answer. Answer: the catalyst, manganese dioxide, will not be chemically changed during the reaction. The manganese dioxide increases the rate of the chemical reaction but remains chemically unchanged at the end of the reaction. It is acting as a catalyst. The graph above shows the volume of oxygen gas produced from the uncatalyzed decomposition of a certain amount of hydrogen peroxide with time. Click the Catalyst button to observe the new graph obtained if a catalyst is present. Compare the heights of the two graphs. Discuss and click Next. Answer: the same amount of gas is produced in both reactions. A catalyst does not affect the overall yield of the reaction. The graph above shows the energy profile of the decomposition of hydrogen peroxide in the absence of a catalyst. Click the Catalyst button to view the energy profile of the same reaction in the presence of a catalyst. A catalyst works by changing the mechanism of the reaction. It provides an alternative reaction route. What can you deduce about the activation energy of the catalyzed reaction from the graphs above? Click Next for the answer. Answer: the activation energy of the catalyzed reaction is lower than that of the uncatalyzed reaction. Look at the Maxwell-Boltzmann distribution curve. Click the EA1 button for the activation energy of the uncatalyzed reaction. Click the EA2 button for the activation energy of the catalyzed reaction. Discuss the effect of lowering the activation energy of a reaction. Click Next for the answer. Answer: by lowering the activation energy, the number of particles having the minimum energy for an effective collision to occur increases. Thus, the rate of reaction increases. A catalyst is a substance that increases the rate of a chemical reaction without being chemically changed itself. A catalyst does not affect the overall yield of the reaction. A catalyst works by providing an alternative reaction route with a lower activation energy. The lower the activation energy, the greater the number of particles with the minimum energy needed for an effective collision to occur. Thus, the rate of reaction increases. Catalysts can be divided into two groups: homogeneous catalysts and heterogeneous catalysts. A homogeneous catalyst is a catalyst which exists in the same phase as the reactants. The process is described as homogeneous catalysis. Homogeneous catalysis involves the formation of an intermediate compound. The catalyst that is consumed in the first step is regenerated from the intermediate compound. Intermediate compound gives product and catalyst. Iodide ions are oxidized to iodine by peroxodisulfate 6 ions. The overall equation is as shown. Suggest a reason why this reaction would require a high activation energy. Answer: the iodide and peroxodisulfate 6 ions are of the same charge, both negative. A large amount of energy would be required to overcome the repulsion forces between them. The oxidation reaction is catalyzed by iron to ions. The catalyzed reaction takes place in two steps. First, the Fe2+ ion gives an electron to the peroxodisulfate 6 ion. The Fe2+ ion is oxidized to Fe3+. Then, the Fe3+ ion takes an electron from the iodide ion, which is thus oxidized to I2. Only a very small amount of Fe2+ is needed to speed up the rate of a reaction. How does the mechanism shown explain this observation? Click Next for the answer. Answer: Fe2+ ions are regenerated and can therefore catalyze the reaction between other peroxodisulfate 6 and iodide ions. The activation energy for each step in the catalyzed reaction is much lower than that of the uncatalyzed reaction. Suggest a reason for this. Answer: both steps in the catalyzed reaction involve a reaction between two oppositely charged ions. There is therefore no repulsion forces to overcome. Although there are two steps in the catalyzed reaction, the overall activation energy is less than that of the uncatalyzed reaction. Catalysts can be divided into two groups: homogeneous catalysts and heterogeneous catalysts. A homogeneous catalyst is a catalyst which exists in the same phase as the reactants. The process is described as homogeneous catalysis. The catalyst is regenerated at the end of the reaction. A very small amount of catalyst is needed to speed up the rate of a reaction.